we've got here Mesa Base Strategy 888. Name that because it uses 8 KT88 tubes. And I've got to remove all these. Fortunately, I will give, I call them like I see them, even on brands that maybe I have reason to mistrust. But they have these nice tube clamps. Much better design than the ones that go over the tubes and press down, because the metal against the glass on those often kills KT88s and 6550s and SVTs and other similar amps. So I'll be removing all the big tubes. Most Mesas don't have any bias adjustment whatsoever. This one has a very convoluted bias setup with a LED that glows at a certain point. You can read all this if you want. And has trim pots for each quad of tubes. The trim pots in here have been chewed up from someone using the wrong screwdriver, and I've got to replace them. And that's not going to be easy. I'll show you why in just a moment. All right, here's the issue. And it's going to sound like I'm just complaining, blah, blah, blah. I don't care how long it takes me to do this, really. I get paid to do the work, and however long it takes to do that work. When a designer, I'll call them that, makes things especially difficult to work on, it just costs the owner more money. So, I should be glad that these things take forever to work on. I'm not, because I don't like charging people money for this, but I've got the bias board, the bias switch boards loosened. I'm not sure if they need to come out or not. And the trim pots are here on these boards, which have all the output tubes. And I'm afraid I'm going to have to remove the output board to access both sides to change out the trim pots. So let's see. If we're really lucky, this will lift up without any major work other than removing these screws. You can see here, in the past, I already repaired major issues with the screen supply on this amp, where things had burned badly. When I get this thing entirely where it needs to be, I'll redo that silicone there. But this amp had caught on fire before, and I'd done repairs to the traces, and subsequent to that, the trim pots got messed up. So back into it we go. Okay. This board has got some solder joints here that make it very difficult to lift this up. I must have lifted this filter cap board up to access this, to get enough slack. There's just barely any room to turn it sideways. Let's see. You can see the repairs I did before, and you can see where things had burned. Am I thrilled with this work? Not especially, but it's what you have to do sometimes on these things. You just to keep the damn thing working, because of the traces not being done right to begin with. Things not rated for current. They don't plan for current, and they don't plan for heat. And you go on the forums and people say, all Mesas do that. It's part of the tone, man. So many compromises people are expected to swallow for that logo. It's like people who are really into British sports cars from the 60s and 70s, I guess. That's a charitable interpretation. Except that most guys who get into British sports cars learn to fix them themselves. They don't expect them to be drivable every day. Come on. These plastic standoffs are not my friend. I think it's criminal to have this much mass in an amp at this price point secured in place with little plastic standoffs to get fragile. All right, now I have access to flip this up. There's the trim pot in question. Let me adjust the camera. All right, there's the poor chewed up trim pot. It's chewed up, but it's turning. Let's see what measurements I get across it. Oh, it's not a single turn pot. Or is it a single turn pot that's lost its mechanical strength? They only have 2 of the lugs in use. 6.4K. I like to wire bias pots up like that with all 3 lugs used, so if the wiper were to fail. All right, small Phillips head no longer fits it. The plastic guy's too chewed up. Now it reads 0 ohms. But it still turns. Read 0 ohms. So yeah, it was not a multiple turn pot. It is a single turn pot that has mechanical failure. So it needs to go away. So let's see if we can do this in situ. All right, so the first thing I want to do is tin the iron. I want to apply some fresh solder to these old connections for this pot. Got a fresh spool of desoldering braid. Every time I use this, someone says you need to get a desoldering station. And that's kind of true, except that the good ones cost a lot of money. And you end up spending as much time cleaning the tips out of desoldering stations as you do doing work with them. As I'm not doing a lot of IC level stuff, and I'm not doing a bunch of surface mount stuff, for the most part, desoldering braid works really well for me. Here's where it gets a little bit tricky because I got these leads that are bent over. I'm not sure how much of this is visible to the camera, but the work comes before the cinematography. I'm an amp tech who puts stuff on YouTube. I'm not a YouTube channel that needs amps to have content. All right, now all 3 are mechanically unsupported. Let's see how much of this I can get out without it burning anything. Double plated. All right, so here's the trim pot in question. Did it take up a little bit of that pad on the other side, or is that just a ring of solder? No, it's just a little excess solder. Let me get the solder off of this side, if I can do it without twisting the wires at the other end too badly. Complication. The new trim pot is slightly wider than the old trim pot. To buy it space, I need to move these resistors, or at least this resistor, to the other side of the board. So let me do that real fast so I can install the pot where it's supposed to be. Well, it's installed, and it's installed neatly. I've got a little bit of flux to clean up, but we may have a problem. The old trim pot had the adjustment just a little bit farther to the right, and there are holes in the chassis. I'm not sure if they're going to line up, so let me check that real fast. May need to go to a plan C. While it's not centered the way the old one was, it is still adjustable if you peek at it just right. So this will work even if it's not great. I mean, this is not a great design. If someone said you need to do something with a dual bias supply for 2 quads of KT88s per side, I'll tell you one thing, I would not be using a little 1/3 watt or 1/4 watt trim pot. I would be using stuff like you'd find in a Fender, a real 10K or 22K pot, chassis mounted. You can get high quality chassis mount trim pots with higher wattage ratings in the 20 to 22, 25K value, and something that'd be a little more trustworthy and more rugged, because even this new Burns trim pot I put in there is not, they're supposed to be, you put them in a circuit, you tweak whatever, you bias a transistor, and then you leave it. It's not something for repeated adjustments. So, but here I am arguing with Randall Smith again. He doesn't care. And it's like arguing with the wind. A stinky, stinky wind. Okay, I've got the amp powered on through a current limiter, which also lowers the voltages a bit. And I've got the tubes out with it in standby at the grid of these output tubes now. I got negative 66.4. The same. Same, though they're fluctuating between 0.4 and 0.5. That's fine. And that's with the bias trim pot at what should be its most negative. And the old one, where I don't trust the pot, negative 75 volts. Okay, yeah, Mesa wired the trim pots up backwards to how I would normally consider it. So clockwise equals colder. So negative 75.2 now on the quad that has a new trim pot. Negative 75.2 on the old, where we have the unreliable trim pot. So that should correlate to the coldest bias when the tubes are put back in place. Let's see what that goes to when I turn off the current limiter, just out of curiosity. So now, instead of negative 74, it's negative 77.5 on both. So that's good. So I know that the trim pot does actually adjust the bias. And that whole bias measurement thing is just putting some cathode stuff through an LED to set the current draw that they want. I'll try it their way, but for a tech, it's not necessary. I don't like bias supplies that use LEDs because it just adds a whole bunch of complication to a bias circuit. And that's something that you want to be as simple and reliable as possible, with much sturdier pots in this thing. But, you know, so be it. Let's power it off, and I'll make sure everything's discharged before I pull the other board to access all that fun stuff. All right, the second one's installed, same as the first. I'll clean up that flux in a minute. What I want to do first, though, let's see if I can show this. Someone over-tightened this board in the past, and the board itself has got a curve in it, and there's a couple different curves where this thing's been clamped because there's no standoff beneath there. It's just a screw pulling straight down, and the board can flex. I've confirmed that none of the traces have cracked, but I want to reflow the solder joints on these octals. As that board has flexed, those can move. So I'm going to do that real fast. Nothing exciting about it, but just to make sure that everything is where it wants to be without any stress on the solder joints. Okay, now the next issue I have is that with both trim pots installed and working, there's a 3-volt discrepancy per side. This one maxes out at negative 78.6 volts, and this one maxes out at negative 75.2. That 3-volt discrepancy is worrisome. Doesn't seem like a lot, but it shouldn't be there. And I'll show you what I think I need to do, because the amp says Mesa on it. These 2 caps here and here, those are the output coupling caps from the phase inverter. And Mesa uses 400 volt caps. They often leak. I think the one going to this side is leaking a little bit, which makes this side less negative by 3 volts. And that's with no power tubes and no current. This amp was having some strange sounds before I discovered those trim pots and the bias supply were shot. So I suspect that that's going to be the issue. They've got it all gooped up a little bit. That's no big whoop. The main issue is that there's just no real estate. Let's see what I can do. Let me power it off. And I want to discharge the caps before I get in there. So let's see where we're at on that with the amp in play rather than stand by and power it off. It's draining down. It's 400, 380. So I'm going to drain that down enough where it's safe for me to get in here and pull things before I disconnect things. And we'll get those caps out. I think they're 0.047, 400 volts. And that's probably the source of our woes. The issue is one side is really close to this connector, the other side's really close to this regulator. Regulators get pretty warm. I would never put a film cap that close to a regulator, especially one as important as output coupling caps. But as is often the case, it's very cramped corners. I don't want to melt this connector, which is plastic, and it's less than an 1/8 inch away from where I need to solder, and the other end is hidden by all this stuff. So I'm going to pause here because I'm about to say a bunch of words that YouTube doesn't want me to say in these videos. Well, we've got good progress. Those orange drops are out. We've got some 630 volt Panasonics there. You can just see they're a reddish color rather than the orange, but they're much more suitable for this particular amplifier. The bias trim pots are working just fine. The LED circuit that they have does not. That could be a problem with the LEDs, could be a problem with the resistor. It seems crazy over engineering. I just measured the DCR current and voltage and all that fun stuff, and I can report that one bank of KT88s is at 51.4%, and the other one is at 54.8%. So I think we're going to be just fine. I'm going to let this run like this for a little bit and reconfirm the bias after everything gets warm, and then see what it sounds like. Well, I was hoping this would be the playing test and all would be great. And in the grand scheme of things, everything is great because this amp was making some horrible noises before. but it is not very loud. That's with the master at 10. This should be infinitely louder. If I crank it, you can hear the preamp break up. So the problem's not there. Let me plug into the effects return. I'm looking to see if it has a effects thing. No. So the problem is after the effects return and before the output tubes. This thing, as far as I can tell, I don't have the schematic, has two IRF 820s or similar MOSFETs doing the job of two-phase inverters. Either one of those could be bad, probably both, or it could be a component in that part of the area. What little I can hear is sounding good, which is good because before it was going horrible noises, only infinitely louder and less Muppet-like. This thing is not being a cooperative little beastie. I can trace signal all the way from the input to the power tubes and measure voltages, and everything is just fine. The DI out sounds fine. I can measure voltages on the plates of the output tubes, and I should be hearing that through the speaker, and I'm just not. And in some apps, that would make me think, oh, we've got a potentially bad output transformer. And that's possible here, but something else draws my eye. Mute on and less speaker in. So they've got some kind of circuit in here to detect the presence of a speaker plug, of a speaker cable plugged in, which is going to be one of these shunts. And it could be a dirty shunt contact, or it could be something in that mute circuit. But that is much more likely than a bad output transformer. Let's hope. So I've got to take all this off the back panel to access this PCB and see what's being censored. Not censored, what is being sensed, what the sensors are picking up. And there's a couple of optocouplers and relays around tucked in places, any one of which could be malfunctioning and muting the output. So let's see what I can see after I get that out. Good Lord, to get the jacks poured out, I had to loosen that board and that board again to get the room. And there's some discoloration, just to focus right. Discoloration on all these jacks from the smoke from when the output tube board burned before. And a lot of dirt and yuck. There's a factory bodge there where they stripped the insulation back too far. I clean all this stuff up. And there's a relay here. I suspect might be part of the issue. I'll know more in a little bit. Gotta get basically a layer of soot and grease off everything first. Okay, got it cleaned up quite a bit. You can still see the dark where it's hard to get up. And I reflowed some solder joints. And what seems to be happening is that the ring and ring normals of these stereo jacks being used for speaker jacks are all tied together. So as soon as something is plugged into any one of these jacks, the sleeve of the plug, the speaker plug, will connect the ring to ground. As soon as that happens on any one of those, that whole network is 100K away from the negative of this relay. So if you plug a speaker cable in, that relay energizes and flips so that it's in this position and this position. If it's not activated, i.e. nothing's plugged in, this tap, which is the 8 ohm tap, is shunted to ground. Now this relay is really difficult to remove. I can do it if it is actually bad. But the best way for me to test this, since it's only shunting the 8 ohm tap to ground, is I'm going to disconnect this yellow wire here, which is the 8 ohm connection to this. And at that point, that relay should be doing nothing. I want to see if I then have output. I either have a faulty jack, more likely a faulty relay, or possibly there's a problem with the supply going to the relay. I think that relay just got too hot. So I'm going to disconnect this wire, put it all back together, and see what we got. Okay, with the 8 ohm tap physically disconnected so that relay cannot mute the output of the transformer, the output transformer, we have sound. It's not great sound. I'm just going through a little 1x12 cab here. I've got going into that and to a dummy load to get the 4 ohms without blowing the guitar speaker wattage. Now that this amp makes sound again, I can hear that there is a buzzy sound. That sounds like the fan noise, and it's either the fan noise or a bunch of bad filter caps. So I'm going to disconnect the fan and see what's up. I'm not sure how far back to put it together right now. I'm going to disconnect the fan because that's a ribbon cable kind of thing. Anything else is going to have to wait until I get the output fixed. This is not a fix to disconnect an output transformer tap, secondary, but it does let me know that that relay, either the relay is at fault or the power to the relay is faulty. Given the placement of that relay and how much heat has been in that area and how cheap they are, I do suspect it's a bad relay. So we will revisit this after that arrives, and I'll disconnect the fan. If that noise goes away, it's probably where the fan is connected. Not worth videoing unless something else is awry.